In this example, we want to find what's called an nth degree Taylor polynomial center at C. C in this case is pi over 4. That can be used to approximate the function f of x equal to sine of x. And this is the nth degree polynomial. And so we want to find a second degree polynomial, and then we would need to find a polynomial up to the second derivative. So if we want to find a third degree polynomial, then we will need to go to the third derivative and so on. And so since here we just want to find a second degree Taylor polynomial, then what we need to find is this. So we need to find so this is called a second degree Taylor polynomial. And in this case, C is pi over 4. And in a few minutes, when we look at the graphs, we get a better understanding what this pi over 4 represents. And then we need the first derivative at C, and we need the second derivative at C. And so for this particular Taylor polynomial, we're using the function f of x equal to sine of x. And so to get f of c, then we just need to evaluate the function at c. So this will be f of pi over 4, which is sine of pi over 4. And sine of pi over 4 is the square root of 2 over 2. And so now we got f of c. So next we need f prime of c, which is the first derivative at c. The derivative for sine of x is cosine of x. And then now we need f prime of c. So we evaluate the first derivative here at c. And again, c is pi over 4. So in the place of c, we put pi over 4. And this will be cosine of pi over 4, which is also the square root of 2 over 2. So now we got f prime of c. Next, we need the second derivative at c. And so we need to calculate the second derivative and then evaluate it at c. And the derivative of cosine of x is negative sine of x. And now we need to evaluate this function, the second derivative function here at c. So this be negative sine of pi over 4. And this will be negative square root of 2 over 2. So now we got f of c, we got the first derivative at c, we got the second derivative at c. Now we are ready to form the second degree polynomial. So second degree Taylor polynomial, f of c is the square root of 2 over 2, and then plus f prime of c, or the first derivative at c of c, so the square root of 2 over 2, and then minus times x minus, again c is pi over 4, so we have x minus pi over 4, and then plus this. The second derivative at c is negative square root of 2 over 2. And then c, in the place of c, we have pi over 4. And then 2 factorial is just 2. And so this is what we call a second degree Taylor polynomial representing the function sine of x. So now we will look at the graphs of sine of f of x equal to sine of x and compare the graph with the graph of the second degree polynomial. Then we will see that the two graphs, they will overlap each other around values near pi over 4. And so now let's look at the graphs. The blue graph here is the graph for sine of x, and the red one is for the second degree polynomial. And pi over 4, this is pi over 4 right here. And then if we look at the graphs, they overlap from here to about right here. And so for values around pi over 4, this is pi over 4. And then for these values right here, the two graphs, they overlap, meaning they have the same value. So we pick the number near pi over 4 and then evaluate it using the second degree polynomial, and then evaluate it using the function sine of x. We will see that the two values are similar, about the same. And so that's what the Taylor polynomial is used to approximate values for functions. And in this case, the function is sine of x.